Dear friends, welcome to my channel. My name is Johannes. Now let's continue example 4.7, which is frame example 3. The frame shown is loaded with 1200 Newton load and is supported by pinned supports at joint C and D at the bottom of this structure. So the frame is in static equilibrium initially. Now what will be just the external reaction force, and also identify two force member and the external reaction, and determine the components of all forces acting on the frame. So this is the structure. You have vertical member and inclined member with a pulley system, 1200 Newton. Now let's continue. First free body diagram. You have to draw overall free body diagram to calculate the external reaction, and then disassembling the frame into its members or dismember into each component. Then you can find the individual components. So this is the free body diagram. So you have pin connection at the bottom. You have CX and CY, then DX and DY at the bottom. Then this is a pulley which is going down, so with 1200 Newton. So dimensions are given. So as much as possible, you should be consistent with the system of measurement. You can change this centimeter into meter. Then finally, it will be compatible. So take moment at C, summation of moment at C equal to 0. So you have 1200 creating clockwise minus 1200 times 0.9. So 0.9 is the moment arm. So you have 10 centimeter plus 30 centimeter from here up to here. Then if you add 50 centimeter, you will get 90 centimeters. Then change into 0.9 meter. Then you have dy. So dy create counterclockwise to this direction. Then you have 50 centimeter. So 0.5 equal to 0. Then dy will be 2160 Newton upward. Then next, summation of force in x equal to 0. Cx you have to the left direction, and dx again to the left direction. This is assumption. We will correct later on. So you have this equation. Cx and dx are equal. And summation of force in y direction equal to 0. So negative 1200, which is downward, plus dy plus cy equal to 0. So cy, let us assume upward, then we can change. So cy equal to 1200 minus 2160. So you get negative 960 Newton. This shows the assumption for cy, which is upward, is not correct. So change to downward direction. So 960 downward direction. So change the direction downward while disassembling the frame. You see, this is just change it to downward. So let us compute now. Member CEF, you have pin here, you have FX and FY, AX and EY, then CX, CY. Then member BED, again you have tension, then EY and AX, then DX, DY, then pulley you have. So assume X to the right positive and Y upward positive. Then let us start. Just starting member, take less unknown reactions. Let us take member BED, summation of moment at D equal to 0. Then AX you have, AX, this is AX counterclockwise, 0.6 distance you have. Then minus T times 1.1. If you add 0.5 and 0.6, it will be 1.1. So AX will be 2200 Newton to the left direction, which is assumption is correct here. Then here you should change. You should change this direction. Already, just this is to the left direction, so this is correct to the right direction. Then again, summation of force in x equal to 0 minus EX plus DX plus T equal to 0. So minus EX plus DX plus T equal to 0. Then DX will be 1000 Newton. DX will be 1000 Newton to the right direction. Then summation of force in y equal to 0, then negative EY, this is downward, plus dy equal to 0, then EY will be in the downward direction. So EY is in the downward direction. So once you have downward direction, you should put here in upward direction. So action and reaction force should be used. Then summation of moment in F. You go to member CAF, summation of moment in F equal to 0. Then AX, which is this one, multiplied by 0.5, because you have vertical distance from here up to here, 0.5. Then minus EY. EY is this one, clockwise. You have distance 0.3. This distance is equal to 0.3. Line of action of the force pass through this point. So you have 0.3 meter. Then minus CX. CX is this one, clockwise again. It will create clockwise. So dimension is given from here up to here, 0.5. Then you sum up 0.6. Then 1.1 minus CX. Then plus CY times 0.8. CY is this one. So it is counterclockwise. 0.5 plus 0.5 will be total 0.8, because this is 0.5, this is again 0.5 meter. So total 0.8. Then CX will be this amount. So CX will be 1109.09 Newton. Then once you get this from CEF, then summation of force in X equal to 0 again, minus CX plus EX minus FX equal to 0, then 1090.91 Newton. So summation of force in Y again, you can calculate negative CY plus EY plus FY equal to 0. FY is this one. So just FY is 1200 Newton. 1200 Newton. So this is just upward. We assume upward. So it is correct, positive. So you should change this one to upward direction. You can correct like this. If result is positive, assumption is correct. So you will put the correct direction. Then you go here. You will change this one to downward direction. Downward direction. Clear? Okay. So let's go to motion now. Example 4.8 is motion. So you have motion. This motion is just fixed at this point at C. This is free to rotate, pin connection, free to rotate. Then if you push this one, then the machine is just exerting a force on point E. So the shear shown is used to cut and trim electronic circuit board laminates. Then for the position shown, determine the vertical component of the force exerted on the shearing blade at D. So the vertical component on the shearing blade at D, you are asked here at this point. Then the reaction at C. So the first step is identify the two force member in this motion. So you have two force member. If you see member BD, it is just exerting sometimes to this direction. If you release this force, if you exert, it will act like this. So it is a two force member. So member BD is a two force member. Now let's go to the solution, free body diagram. Just coordinates as shown. Then this is just 400 Newton with 30 degree with from vertical. So you have A1, which is downward, AX again to the left. Then dimension is given. So FBD is just two force member. So from the moving part, it can be seen that BD is a two force member. It will exert like this. If you compress, it will exert again at D. So it is a two force member. So from member ABC, you have AX component. AX is this one, just sine of 30. You have to this direction, horizontal. So it is negative direction. So 400 Newton times sine 30, which is 200 Newton to the left. And AY again, you have 400 Newton cos 30 downward. So this is downward. AY is down. This is downward direction. Then take out the dimension of this FBD. So FBD, you can draw triangle here, triangle with 90 degree. Then you have dimension 25 millimeter here. This is 25 millimeter. So you put 25 millimeter. and vertical you have 60 millimeter. So for this component, FBDX horizontal and FBDY vertical. So calculate this dimension first. By Pythagoras, it is right angle triangle, then 25 square plus 60 square under square root, you get this result from D to B. Then FBD means cos theta. FBD cos theta. So cos theta means this one. Cos theta is 25 over 65. Adjacent over hypotenuse times FBD. FBDY is FBD times sin theta. So sin theta is sin theta. If you calculate sin theta, opposite over hypotenuse. So 60 over 65 times FBD. So with this, now let us create an equation. Let us have an expression on this one. Summation of moment at C equal to 0 because you have more reaction at point C. So minus FBDX. FBDX you have you can just calculate like this. Component you can draw like this. This is FBDX. Here, this is FBDY. For this FBD, it will go like this. FBD is like this. So FBDX, which is clockwise, it will create clockwise times 45 at point C. Then minus FBDY, this is FBDY. At point C, you have distance from here up to here, which is 0.3 or 30 millimeter. FBDY times 30. Then AY times, this is AY. So you have distance from here up to here. Again, you have distance. Then this is 300. The dimension of AB is known, 300 millimeter. Then this is 300 cos 30 degree. Cos 30 degree. Cos 30 degree. Then this is 300 sine 30 degree. This is 300 times sine of 30 degree. Clear? So you have here AY, which is the vertical component of 400 Newton force. We have 200 Newton, which is 346 Newton downward. Then AY, already known. Then 300 cos 30, which is this one. At point C, you will add 30 millimeter. This distance. You will add this plus this one. So 30. Then it is just counterclockwise. AX again, AX means this one. Horizontal component. So you will add 300 sine 30, then plus from here up to here, which is 45. So like this. Then simplifying and substituting the above values, you get this result. Summation of moment at C we are taking. So after simplification and substitution of FBDX, FBDY, you get this expression. These values are FBDX and FBDY. Then finally, if you solve, it will be like this. Then FBD will be this one. So FBD is compressive force, 3097.62 Newton compression. It is compression force for this moving mechanical part. Then the vertical component of the force exerted on the shearing blade at D will be FBDY. FBDY already know, which is FBD times FBD times have this one. If you substitute 60 over 65, then finally 2859.34 Newton. Then again from a free body diagram of the member ABC, this is the free body diagram. You have CX, CY. To get CX and CY, you will use the equilibrium equation. Summation of force in X, summation of force in Y equal to 0. Then you can calculate already FBDX known, which is this one, already calculated. FBDY already known. Then FBD is already, you can substitute. Then finally, you can calculate the force at point C. So the force supported by the pin at the joint C will be summation of force in X equal to 0. FBDX, which is to the right, minus AX, which is this one, to the left, then minus CX equal to 0. Then if you substitute FBDX 25 over 65, then multiplied by FBD, then 400 times sine 30 minus Cx equal to 0, then Cx will be this one. Cx will be this Newton. Summation of force. Okay, this is, I think, Cx minus Cx. Already we get positive result. So not to the right, to the left. It should be to the left direction. And the summation of force in y equal to 0 will be dy. This is vertical component minus ay, which is downward, then plus cy equal to 0. Then cy, you get this result. If you sum up, then it will be just negative again. Negative result you get for cy. So cy should be downward. Cy should be downward force. Then you can calculate like this. Then magnitude of the force supported at the pin C will be square root of Cx square plus Cy square. Then you get 2701.4 Newton. Then finally, the direction will be tan inverse of Cy over Cx, 68.45 degree. Then you can draw like this. So since Cx is to the left direction, this is Cx, this is Cy, clear? So it is just like this. So theta is this one, the angle or direction of the force. So as exercise, we can try this one, frame 1. For the frame and loading shown, determine the components of all forces acting on the member A, B, E. So you have here two joints, pin connections. So you will just put force. Four forces you have, Fx, Fy, and Xey. Then you can just dismember. First, from overall free body diagram, you can calculate any force which is supported in the pin connection. Then disassembling of this frame, you have horizontal member BCD. Then you have vertical component with just force, unknown force. Again, you have here EX, and similarly for this one also you have Fx again. You have Fx again. You have then Fy. So from overall equilibrium equation, you get this 600 and 1800 Newton. Then from this dismember, choose a member with less unknown reactions. Then you proceed like that. In exercise 2, you can see this is just a symmetrical A-shaped structure experienced an external force applied as shown. This is 300 Newton applied. Then you have angle 60 degree, or then first overall free body diagram we draw. This is overall free body diagram. So take moment at point A, you get force at joint E, which is roller. This is one force only. This is two force. So as the drawing shown as the so once you get external reaction, then separate the structure into individual components and draw a free body diagram of each component. Then you can find the individual forces or the reaction forces. So apply Newton's third law. So Newton's third law for each joint. This is to the right direction, so this should be to the left direction. You just like that. FPD is just a two force member. This is a two force member. You can see it is just supporting this A frame at the middle, BD. So it is a two force member. So it will act like this, action and reaction force. Then again you have here FAX, then FAY. So like this you can finalize. So you can have, I think we have solved this problem in the first tutorial, and this is also we have solved it. Again, you go here, this is inclination, then you can apply distance with this 10 times cos 20, etc. You can proceed, and then this is also similarly we have solved these problems. This is frame. Again, you have another frame. Already this is already solved. So try this worksheet exercise. I think it will be easy to compute. So thank you very much. So I think thank you very much for watching this video. If you have any question or doubt regarding this tutorial problems, please forward through comment suggestion box and I will reply on it. So thanks again.